Hello everyone, this is part 2 of my Pascal live solve and solution explanation. If you haven't seen the previous video, I'll be doing these problems for the very first time and explaining my thought process as we go along. Last video, we did the first 10 problems of the contest, so if you want to see that, then click here. Now, let's dive straight into part B. In the diagram, we have a triangle. I'll draw that over here. If this one, and this one, and this one are equal, and this is 80. Now it wants the measure of angle ACD over here. So since angle ABD is 80 and AB equals AD, this triangle is isosceles. So this means that angle ADB is also 80 degrees. Moreover, since angle we want angle ACD and AD is equal to DC, triangle ADC is also isosceles. So if we let x is equal to angle ACD, then by the external angle theorem on angle ADB, we have that 80 degrees is equal to 2x, so x is equal to 40 degrees. So our answer is E. For question 12, we have 10 positive integers summing to 30. 6, 7, 8, 9, 10. And we want the largest number that can be used in the sum. So if we say make this one the largest possible, since the sum is fixed, this is equivalent to trying to make the first 9 numbers as small as possible. The smallest positive integer is 1, so we're going to put 1 in all of them. This has a sum of 9, so the largest number is going to be 30 minus 9, which is 21. The answer here is C. For question 13, we have a square and a triangle attached to each other. This is 8, this is 17, and the bottom is a square. So now, by the Pythagorean theorem on right triangle ABC, we note that BC is going to be equal to root 17 squared minus 8 squared. You can plug this into your calculator to get that this is 15. Alternatively, you can recognize the 8, 15, 17 Pythagorean triple. The question asks for the area of square BCDE. The area is going to be equal to BC squared, which is going to be 225. So here the answer is C. For question 14, we have the Edmundston Oilers, the mathematician name, that's kind of funny. They played 5 games with an average of 3 goals per game. So, in 5 games with 3 goals per game, this means that the total is going to be equal to 15 goals over those 5 games. If they want their average to increase to 4 goals per game in the 6th, then after that, they're going to need to have 6 times 4, which is going to be 24. Therefore, in the 6th game, they're going to have to score 24 minus 15, which is 9 goals. That's a lot of goals. So the answer here is D. In question 15, we have 3 students taking a quiz. These are their answers. All right. 15, 36, 24, 20, 38, 24, 15, 54, 24. We know that each of these students got exactly 2 questions correct. Okay, so let's look at question 3 first. If the answer is not 24, then they all get it wrong. Then they all have to get the first 2 questions right. But clearly all their responses are different for each of the first 2 questions, so this one must be correct. So here the answer is 24. Now let's look at the first 2 questions. We note that 15 is shared between the first and third student. So if 15 is the wrong answer, then the first and third students would both have to get 2 questions correct, which would have to be this one and this one. But since those answers are different, that's not possible. Therefore, 15 also has to be correct. So now both of these two students each have 2 questions. Finally, the second student needs to have his second question as well, and that's going to be 38. The question asks for the sum of these 3 numbers, 15 plus 38 plus 24. That is 53 plus 24 is 77. So the answer is B. Alright, moving on to question 16. We have 34 students sitting side by side, including 2 students named Pedro and Huili. Alright, a line of students. Pedro counted 23 students, including Huili to his left, so this is 23. And Huili counted 15 students, including Pedro to her right. That's 15. Now, in this count, we have that all the people to the left and including of Huili, all of these people are only counted in this one. They're only counted in the top count, in Pedro's count essentially, because Huili doesn't count any of the people to her left. She only counts the people to her right. Similarly, Pedro doesn't count any of the people to his right. So since we know that there's 34 people in total, 34 minus 23 is going to be 11 people in this group, and 34 minus 15 is going to be 19 people in this group. Therefore, since we want the number of people in the middle, this is 34 minus 19 minus 11. There's going to be 4 students. All right, now for problem 17, we have the notation n factorial. Now we're given an n such that n factorial is equal to 3 factorial times 5 factorial times 7 factorial. N factorial is equal to 3 factorial times 5 factorial times 7 factorial. So what do we do with this? Well, we have that 3 factorial is 3 times 2 times 1 is 6. This is 6 times 5 factorial times 7 factorial. And 6 times 5 factorial, we can group this to get 6 factorial times 7 factorial. This is going to be equal to n factorial. So we have that 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1. And we want to group these numbers to somehow get a bigger factorial when combined with 7 factorial. So the next number you have to multiply to 7 factorial would be 8 and then 9 and then 10. So let's see how we can group these. We can get 8 using the 4 and the 2. And then 6 times 5 times 3 is 30 times 3, which is 90, which is equal to 9 times 10. This means that 6 factorial times 7 factorial is going to be equal to 7 factorial times 8 times 9 times 10, which is going to be 10 factorial. Therefore, we get that n equals 10. All right, in question 18, we have 2 circular dials positioned next to each other and an arrow. We want to find how many seconds need to pass when the dials are rotating at certain speeds until they're pointing exactly at each other again. All right, excuse my, okay, I'm going to redraw that circle because it looks kind of bad. Okay, so we have these 2 arrows pointing in some directions, and note that they're only pointing together towards each other at this exact angle. You can't say have them pointing any other angle. This means that they'll have to do a whole number of rotations. So we need that after a certain number of seconds, the total number of rotations, the total number of degrees rotated is a multiple of 360, because this is the condition for when an object is facing the same direction as the beginning. So let's suppose it's t seconds. The first one travels 20 degrees per second, so it travels 20 t degrees. The second one travels 8t degrees. Therefore, we need that 360 divides 20t. We can divide both sides by 20 to get that 18 divides t. So t is a multiple of 18. Similarly, we have 360 divides 8t. 360 divided by 8 is 45. So 45 also needs to divide t. The minimum possible value of t satisfying this is going to be the LCM. So t is going to be equal to LCM of 18 and 45. Now, there's multiple ways to calculate this, but an easy way is to note that this is 9 times 2, and this is 9 times 5. Now, we can kind of factor out the 9 to get that this is equal to 9 times the LCM of 2 and 5. Since 2 and 5 are relatively prime, they're both prime numbers, that's just 10, so the answer is going to be 90 seconds. Okay. In question 19, we have two cylinders. I'm going to draw them here. All right. This one has radius 2 and height 8. This one has radius 8 and height 2. Now, we know that cylinder A is 75% or 3/4 full of water. So let's first calculate the volume of this water. It's 3/4 of the total cylinder, and we're given in the question that the volume of a cylinder with radius r and height h is pi r squared h. This is 3/4 pi r squared h. Substituting our values of r and h, this is going to be equal to 3/4 pi times 2 squared is 4 times 8. Cancel these 4, so the volume is 24 pi. Now let's also calculate the total volume of cylinder B. This is going to be pi r squared h, which is going to be equal to pi times 8 squared times 2. 8 squared is 64 times 2 is 128 pi. Now the fraction that it's full with water is just going to be the ratio of the total amount of water to the total volume of the cylinder. Because, for example, if the volume of the water is half the volume of the cylinder will be half full. In this case, we have that the ratio is going to be 24 pi over 128 pi. Pi cancels. We can divide the top and bottom by 8 to get, this is going to be 3 over 16. Therefore, our answer is A. Alright, moving on to question 20. This is the final problem in part B. A drawer contains 5 black, 3 gold, 2 white socks, and none other. He removes 3 socks from the drawer, and we want the probability that these 3 socks are not all the same color. So we're going to use some complementary counting. We have 5 black, 3 gold, 2 white. The probability that they are not all the same is going to be 1 minus the probability that they are all the same. And we're doing this because it's a lot easier to think about when they're all the same versus when they are not all the same. For example, when they aren't all the same, you could have 1 black, 1 gold, 1 white, 2 golds and 1 white. There's a lot of possibilities. But when they're all the same, it's either 3 black, 3 gold, or 3 white. Now notice that there are 2 white socks, so you actually can't have 3 whites. Therefore, there's only 2 possibilities of these two. If there's 3 black, yes, or 3 gold. So now we just need to calculate the probability that this happens. So we're going to assume that when Jack removes the 3 socks, he doesn't put them back in because that would be kind of random. So what's the probability that we take 3 black socks? The probability that the first one is black is going to be, well, first there's 5 plus 3 plus 2 equals 10 total socks. If he removes all black socks, it's going to be 5 out of 10 for the first one, 4 out of 9 for the second one, 3 out of 8 for the third one. We can simplify this to get, this leaves 2, this leaves 2, this leaves 3. This is going to be 1 over 3 times 4, which is 1 over 12. The probability, this is the probability of 3 blacks. What's the probability of 3 gold? It's going to be similar to the previous one, except with 3 over 10 times 2 over 9 times 1 over 8. Again, we can simplify this. Cancel at 3, cancel at 4. This is equal to 1 over 120. When we add these two probabilities, this is 1 over 12 plus 1 over 120. 1 over 12 is equal to 10 over 120, so this is 11 over 120. Finally, remember that the question asks for the probability that they're not all the same color. So we subtract this from 1, and that's equal to 109 over 120. Therefore, the answer here is E. Alright, that's part B of the 2025 Pascal. Alright, that's it for part B. I'll be uploading the final part of the Pascal solve soon, so be sure to subscribe so you don't miss out on how I do in the end. See you guys soon!